So here we are on the week 4 test, and we're starting this with this idea of constants of variation. And remember, constant of variation is the amount that things change. So when it says varies directly, we are talking about change, and it's a consistent change. So the first thing we need to do is we need to identify the x and the y. Since B changes directly with A, or spins directly with A is the independent. A is the thing that controls, so independent. B is the dependent. It depends. Trouble with my handwriting here. Let's see if we can fix that. It depends on what A does. So let's take a look at the change in these. So for A, the change is 6 to 9, 9 to 12. It's growing each time by 3. If we look at those changes, each of those is a change by 3. Whereas with wheel B, if we look at the changes, each of those is a change by 4. Each time it's growing by 4. Our definition of constant of variation, and this is just something you have to learn. The definition of constant of variation is take the change in the dependent which is the y value, and divide it by the change in the independent. Which is the x. In this case, the change in the dependent is by 4s, the change in the independent is by 3s, and that becomes our constant of variation, 4 to 3. Part B, write an equation you could use to find the number of times B spins given the time A spins. Well, we're using the times wheel B spins, and we're figuring that out based on how many times A spins, and what we know is there is a 4 to 3 relationship. So wheel B will spin 4 to 3, 4/3 times A. So if you multiplied 6 times 4/3, think of it as 6 over 1, and I can simplify. 3 goes into 6 twice, 3 goes into 3 once. 2 times 4 is 8, 1 times 1 is 1, that's 8, and there's the 8 right up here on top. This would be true of any of these. 18 times 4/3 will give you 24. So each time A spins, multiply it by 4/3, you get B. All right, on to question number 2. So question number 2 deals with the concept of slope. So we've talked about slope, and let's do our slope equation. This is another thing that you have to memorize. Slope is the y2 minus the y1 divided by the x2 minus the x1. We've talked before, that means the change in y divided by the change in x. So how do we figure out the change? Well, this one's nice because it goes through the origin. So we know we have the point 0, 0. And it also passes right here at the point 560. So that gives us our 2 points to use. This is our x1 and our y1. This is our x2 and our y2. Now, if you stop and you're doing the problem and you're thinking to yourself, man, how do I know which is the 1 and which is the 2? Well, the good news is it doesn't matter. As long as you keep them together, you could make the 0, 0s, the 2s, and the 5 and the 60 the 1s. I always look for the biggest ones to be the 2s because I know I'm going to end up subtracting next. So I know the next step is going to be to say, what's the y2? It's 60. What's the y1? It's 0. What's the x2? It's 5. What's the x1? It's 0. I end up with 60 to 5, which simplifies to 12. That 12 is a couple things. That 12 is the slope. That 12 is the unit rate. Martha graphed the amount of money she earned, hours she worked. So since it's money earned to hours worked, that slope is also her dollars per hour. So now we can go through and we can answer these 4 questions. We can see which ones are true, which ones are false. Slope of the line is 12. We just decided that. Y-intercept is 12. No. The y-intercept, in this case, is 0. We can see right here that the line crosses the y-axis at 0. When you're thinking y-intercept, you're thinking y-axis, which would keep going on that way if we drew it, and line, where do they meet? And in this case, they meet right there. So the y-intercept is 0. If Martha works 7 hours, she'll make $84. Well, let's see if that's true. If Martha works 7 hours at $12 per hour, is 7 times 12, 84? Yes, it is. That's true. The equation for the line is y equals 1/12 x. Nope. The equation for the line is always y equals the slope times x. We actually, in math, we have simplified that. We always call the slope m. So y equals mx. So for this particular line, the equation would be y equals 12x, since 12 is the slope. All right, so there's a good review. You can go back and look this one over. Let's move on to the last side. Graphing proportional relationships. So Brooke has a painting that, or Brooke's painting used the following amount of primer and paint for the job. So 5 to 2.5, 10 to 7.5, 15 to 15, 20 to 25, 25 to 37.5. Graph the values. Here's the graph we ended up with. Is it proportional? Well, here's what we can look at. We can very quickly look at the fact that we can connect those 2 points, but they don't connect everything else. We could connect those 2 points, but they're not going to end up connecting everything else. You cannot draw one straight line that goes through them all. So since they don't form a straight line, they are not proportional. The other way to tell that they're not proportional is to go back and just compare 2 of them. So let's compare 20 to 25. Let me turn off my diagonal line here. Get rid of all those things I just drew. Let's compare the point 15 to 15. We're starting to have some technology issues here. Let's try that again. Let's compare the point 15 to 15 to the point 20 to 25. Are those the same? Well, we know they aren't the same. 15 to 15 is actually one whole. 20 to 25 is not one whole. Since they are not equal, we know that this is not proportional. So our two ways of telling proportional, one is, do they form a straight line? Two is, are the items equal to one another? In this case, they are not, so we know this is not a proportional relationship. All right, there you've got some work to study from. Remember, concept 4 and 5 will be on the next test, so use this video to study concept 4 before you do the week 6 test, and concept 3 and 4 before you do the week 5 test.